What is up, Prealgebra? This is lesson 59, where we are talking about experimental probability. Now, before we jump into experimental probability, let's remember what theoretical probability. Remember, theoretical probability is when you just look at numbers only. So, for instance, on a dice, there's 6 sides, and one of them has a 1. So if I want to find the probability of finding a 1, there's one side that has a 1 on it, and there's 6 sides, so it would be 1 out of 6. On experimental probability, you have to do an experiment, because it's called experimental probability. Or sometimes it's called a trial. So for an experimental probability, we take the number of times that what we want to happen actually happened and divide it by the number of times that we tried. So here's a little scenario where we're talking about flipping a coin. So maybe we want to find out, is this coin fair or not? So first time we flip it, we get a heads. So the probability of getting a heads right now is 100%, or it's guaranteed, based on experimental probability. Because how many times have we flipped it? 1. So that's going to be my denominator. And how many times have I gotten a heads? 1. So the probability of getting a heads right now is 1 out of 1, or 1. And the probability of getting a tails would be 0 out of 1. Okay. Now, as we continue to flip this coin, we flip it a second time, and we get a heads again. So after the second time, now we have 2 heads. 2 times we've gotten heads, and we've done 2 trials. So probability of getting a heads, let's say probability of heads, and probability of tails. Probability of tails is now 0 out of 2, or just 0. As we flip it again, now this time we get a tails. So the probability now would be 2 out of 3, because 2 times we've gotten heads, and we've tried 3 times. And this down here would be 1 out of 3. The probability of getting a tails is 1 out of 3. We can keep continuing on. Maybe I'll skip a few down here, down to like 7. So if we talk about heads, notice we've gotten 1, 2, 3, 4 heads. So my probability of getting a heads would be 4 heads, and I've tried it 7 times. The probability of getting a tails would be 3 out of 7. And I think this is 10 times. Yeah, so if we keep going out of 10 times, we've gotten heads 5 times and tails 5 times. So this comes out to be 5 out of 10, and also 5 out of 10. Okay. So notice, when we only try this a few times, our probabilities are not very accurate. So the more times we do trials, the more accurate our experimental probability becomes. In fact, here in after 10 trials this time, our probability of getting a heads and a probability of tails came out to be the same, which is actually, in this case, also the same as the theoretical probability, which would be 1 out of 2 for each of those. So the more trials you do, the more accurate your probability will be. So let's try a few of these. This is example 2. It says a salesperson distributed free samples at the mall. 15 shoppers accepted the samples and 30 did not. What is the probability that a shopper at the mall will accept the salesperson's samples? So first thing we need to do is we need to say, well, how many of them accepted the flyers? Well, it says 15 of them. So I'm going to put the 15 on the top. The next thing we need to ask ourselves is, how many times did he try to give out a flyer? Well, notice it says 15 did and 30 did not. So so he tried 15 times successfully, and he tried 30 times unsuccessfully, for a total of 45 times. So on the bottom would be 45. We can go and reduce that. I see 5 goes into both of those. 5 goes into that 3 times. 5 goes into that 9 times. So 3 out of 9. Oh, but I can still reduce more. 3 goes into that 1 time. 3 goes into that 3 times. So my probability would be 1/3. So there's a 1/3 chance of the next person or person at the mall accepting his flyer that he's giving out. This next one is practice set B. It says Quinn runs a sandwich shop. Since she added a turkey melt to the menu, 36 out of 120 customers have ordered the new sandwich. What is the probability that the next customer will order a turkey melt? So, how many turkey melts did she sell? 36. How many customers in total? 120. I see that 12 goes into both of those. It goes in this one 3 times, and into that one 10 times. So probably would be 3/10. We could also write that as a decimal, which would be 0.3, or as a percent, which would be 30%. And then, so that would be any one of those would be fine. The 3/10, 0.3, or the 30%. Okay. For practice set C, it says Quinn ordinarily has 200 customers on a busy afternoon. About how many turkey melts should she expect to sell? Well, this kind of goes back to yesterday's lesson that we talked about, lesson 58, where we're trying to find a part. I have how many customers, that's the whole, and I have the percent up here, or that as a decimal right there. So then I need to say the percent as a decimal, say 0.3, times the whole, which is 200, which would equal the part. And so I'll just, on my calculator, say 0.3 times 200, and that gives me 60. So if she was, based on this information that she has, she knows she needs to make sure that she has enough, about 60 turkey melts to sell in the afternoon. Now, is that going to be exact? No, it's not exact, but that's a good estimate as she starts to prepare. She doesn't want to prepare too much and waste, or too little and have people be upset. So that is experimental probability. Feel free to watch this again if you need to. Good luck, guys.